This week, we dive into the declarative plotting interface to learn more about how to set regions for your plot with some of our automatic regions, and how to do things like add layers such as states, rivers, and so on very easily. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week, I wanted to dive back into the declarative plotting interface of MetPy. This is a really powerful feature and definitely helps switch over if you're used to using Genpack, as it sort of looks like Genpack. But to do that, we need to play with some data, and we're going to play with satellite data and learn how to add things like states, rivers, coastlines that we know how to do in CartoPy using declarative plotting, as well as how to set regions with some of the predefined regions that we've got in the MetPy declarative plotting interface for you. So to make the video a little bit shorter and more manageable for a MetPy Monday, I've gone ahead and written the code for actually getting the satellite data. Now we'll go over it, and there are certainly lots of past MetPy Mondays that can help you learn about this if you're not familiar. So we're importing the datetime object from datetime, and we're getting the current UTC time, and then just the date part of that, and storing that as image date. For region, I'm defining that as CONUS, and I'm going to get channel 8 from the Advanced Imager ABI. This is just an F string that's building the URL for where we're going to actually retrieve that data from a thread server. So if I run that cell, we see I get a URL that you can go to and indeed see that it is the current date, the data from the ABI for that. Of course, if you're running this on a different day, your image will look different and your URL will be different. Next, we need to create an instance of a Threads data server catalog. So that's going to be from Siphon, and this helps us go through and easily parse that XML catalog and pull out just the data we want. So we give the TDS catalog object the URL to our data and store that as cat. Now, cat itself is not going to look that interesting, but I'll insert a cell here and remind you that cat.datasets will show you all the datasets that are available in that catalog. And as you can see, there are a lot of images on channel 8 for CONUS just today. Now we're going to get the most recent image and use remote access, and we're going to get an Xarray data array back because that's easy to work with, and the declarative plotting interface works with that really nicely. So let's get that back, and we're going to call it DS. So that's now retrieved from the server, and now we can actually get to the point of the video, which is making our plot. So I'm going to import metpy.plots as mplots. Again, just a shorthand because we're programmers, and programmers are lazy. So first we need to create the image plot. This is the actual data that's going to get plotted, and I encourage you to go back and look at some of our other videos on the declarative interface. But basically we're going to create an image, then create a panel, which is sort of like an axis, and then create a container that can contain panels, which is sort of like a figure. So to do that, I'm going to call it img, and from mplots, I'm going to get an instance of the image plot object. I'm going to set the data to be our dataset DS. And the field, the thing that we want to plot from that dataset, is called sectorized CMI, cloud moisture imagery. And then just to make the plot a little prettier, even though that's not the point of this particular video, I'm going to set the color map to be WVCIMSS, which is a nice water vapor color map. And this happens to be a water vapor channel, mid-level water vapor, I believe. So now we're going to create the panel. And this is a map or georeferenced thing. So we're going to use a map panel object. And on the panel, we're going to set plots to contain our image, just one. And then panel container. So the panel container is sort of like the figure. It can contain multiple map panels or other types of panels. So we'll create an instance of it. And then we will tell it that the panels that we're going to plot in this case are just one, and we called it panel. We could also set the size if we would like. In this case, 10 by 8. And finally, we're going to show the plot. Okay, so we got a warning, but that's safe to ignore. It's something that we're working with on the declarative plotting interface right now. And we have our image. So this looks pretty good, but I'm used to looking at state outlines when I'm looking at a map of the US, of CONUS. So I'd like to go ahead and put those state outlines on there so I can see where exactly I am in this map, for example. To do that in Cartopy, we would use Cartopy features. But in this case, it's going to be on the panel, on the map panel is where I want to put this. And it's not a plot, it's not data that we're putting on there, it's just a layer. You can think of it sort of like a GIS layer. So panel.layers, and this is going to be a list. And I can pass the string states. And that is going to go get the Cartopy, the natural earth features that it uses, and put those on the map for me. So now I can see exactly where, for example, Unidata is. There are some more options that we can use here. So I'm going to go ahead, and you saw that we had coastline already plotted, but I'm going to explicitly plot that. Borders, states, and rivers. You can also plot land and ocean. That fills the land with sort of a tan color, and it fills the ocean with blue. You can also do the same with lakes. I'm not going to do that here because that would put the lakes over the top of our satellite image, which isn't what I really want. And I don't particularly want to emphasize land-ocean differences here outside of my plotting realm. Because you can see there's nothing outside of my plotting realm. But it is nice to have the rivers right on there. I did kind of like that. And we've got a few more features now, such as provinces up here. So that's a really quick and easy way to add these layers to your plot. But what if I'm not happy with the specific region that's being plotted? Well, we can change that. You can specify either a tuple of your own bounds, lower left, upper right corner style, or you can choose from all of these preset regions. And I'll go ahead and go through this slowly in case you want to pause and have a look at them. But I encourage you to go dig through, and most of these are from GIMPAC, so some of them have relatively cryptic names. But any US state, you can just use the state abbreviation, such as CO for Colorado. There are also regions. You can specify US, you can specify the SPC US box even. But there are a lot in here to go through and look at and play with, and this shows you what that bounding tuple looks like, just in case you want to know where that region is. So there are so many of these for all different regions of the world and the US. Indonesia, India, I just saw those go past. Some more regional ones like Northern California, there's a UK. You can see there are a lot of these regions or areas of interest, or regions of interest as they would be called in the GIS world. So what I'm going to do is scroll back up here, and we're going to modify this to change where we're looking. And that is done at the panel layer. So the panel container wouldn't make sense because that could have multiple plots. And the image wouldn't make sense because there we're actually just telling it what data we're going to put and how we're going to put it on there. Is it contoured? Is it an IM show? So panel is where it goes, and panel.area is what we're looking for. So for example, if I wanted to look at the tropical Pacific, or TropPac, we would set the area to that. And when our plot re-renders, now we have the tropical Pacific region. If I wanted to look just over the state of Colorado, I can specify that code and get the default Colorado bounding box. Now some of these bounding boxes are a little far zoomed out for my personal taste. You can always go in and specify a different one. You can also go in and change the projection, but that's a topic for another week's MetPy Monday. But I hope that you see, but really just by using these predefined areas, you can save yourself a lot of time and trouble of having to go and determine your own latitude, longitude bounding box. And by using layers, it's a much quicker and more concise way to add those common map layers than trying to remember all of the CartoPy syntax if that's not something that you're already familiar with. I hope that you found this useful and that you continue to explore our declarative plotting interface as we keep trying to improve it and make it better. If you've got ideas on things you would like to be able to do in the declarative plotting interface, we encourage you to contact us through our GitHub page for MetPy. That's where you can request features or report issues. Thank you for joining me, and I'll see you on next week's MetPy Monday.